On March 6, 1944, something impossible happened. Somewhere over Berlin, in the gray skies above the Nazi capital, German pilots saw enemy fighters they should never have encountered. Single-engine American P-51 Mustangs, sleek silver machines, circled effortlessly above the city, escorting bombers that were supposed to be defenseless. The math didn't work. The calculations didn't work. The physics, as the German High Command understood it, didn't work. For years, German commanders had assured their pilots that Berlin was safe. No Allied fighter possessed the range. The American P-47 Thunderbolt? Maximum escort range, 230 miles with internal fuel, maybe 375 with drop tanks, nowhere near the 560-mile distance to Berlin and back. The twin-engine P-38 Lightning? It could reach Hanover on an exceptional day, but Berlin remained a sanctuary. The mathematics were simple, immutable, ironclad. A single-engine fighter carrying enough fuel to fly 1,100 miles round-trip while maintaining combat effectiveness violated everything German aeronautical engineers had calculated. But the mathematics were wrong. Within minutes of that first encounter, reality shattered the German myth of air superiority. Within hours, 80 German fighters had been shot down over Berlin. Pilots who dominated European skies for 5 years suddenly discovering they were outmatched. Within weeks, the Luftwaffe hemorrhaged its most experienced pilots. Within months, the air war over Germany was decided. The turning point wasn't a new engine. It wasn't revolutionary fighter design. It wasn't superior tactics or pilot training. It was something far simpler. Auxiliary fuel tanks, drop tanks, combined with meticulous flight management that the Germans had utterly failed to anticipate. This is the story of how a relatively simple innovation, external fuel containers that seemed almost mundane to aircraft designers, transformed the entire strategic air war over Europe. More specifically, it's the story of why German pilots couldn't believe what they were seeing, why they kept making mistakes that proved fatal, and why one technological advantage became the psychological and tactical pivot point that sealed Germany's defeat in the skies. Before the P-51 Mustang arrived in European skies, the daylight bombing campaign was collapsing under the weight of catastrophic losses. The strategy was sound in theory. American B-17 Flying Fortresses and B-24 Liberators would conduct precision bombing raids in daylight, when visibility allowed bombers to hit specific industrial targets with accuracy. RAF Bomber Command handled the night raids. Together, they would systematically destroy German industry from the air. The problem was that theory met brutal reality over Germany. Without fighter escorts capable of accompanying bombers deep into enemy territory, the bombers were vulnerable. American planners had believed that the B-17's defensive armament, 13.50 caliber machine guns and tight formation flying, would be sufficient protection. Bomber crews called this concept mutual defense. It was a beautiful idea that died in flames over German soil. On August 17, 1943, American bombers attacked Schweinfurt and Regensburg. The raid was tactically successful. They hit their targets. Strategically, it was a disaster. 60 bombers were shot down. 55 more returned so damaged that they were scrapped. Of 2,900 airmen on the mission, 554 were killed, wounded, or captured. The loss rate was unsustainable, 20% of the attacking force gone in a single day. The mathematics were simple and horrifying. Crews couldn't statistically survive their required tour of 25 missions if losses continued at that rate. Worse came on October 14, 1943, Black Thursday. German fighters attacked another Schweinfurt raid. 60 B-17s were destroyed. Another 17 had to be scrapped. Over 600 airmen became casualties. The American command understood the problem with crystal clarity. German fighters simply waited until Allied escorts reached their fuel limits and turned back toward England. The Luftwaffe pilots called this moment the golden moment, the point when American fighters had to leave and German fighters could attack unprotected bombers with concentrated force. The bombers were most vulnerable at precisely the moment when they were deepest in German territory, farthest from safety, and most in need of protection. The existing fighters were inadequate. The P-47 Thunderbolt had a combat radius of roughly 230 miles with internal fuel alone, extended to about 375 miles with early drop tanks. That was sufficient to protect bombers to targets in Western Germany, but not to Berlin. Not to the Ruhr industrial region. Not to the critical oil refineries and aircraft factories deep inside the Reich where Germany's war machine was being built. The P-38 Lightning had slightly better range, but only marginally better, and it suffered from mechanical problems that grounded it frequently. The 8th Air Force suspended deep penetration daylight bombing raids. Fighter escorts couldn't protect bombers. Bombers couldn't defend themselves without escorts. The entire strategic bombing campaign was effectively paralyzed, at least until someone could solve the range problem. The solution didn't arrive in a brilliant flash of insight. It emerged gradually, through accumulation of engineering knowledge, desperate operational necessity, and American industrial capacity. The concept of external fuel tanks wasn't new. The Spanish Civil War had shown that adding external tanks to fighter aircraft could extend their range dramatically. The German Luftwaffe had experimented with drop tanks in the late 1930s, particularly on the Ju-87 Stuka dive bombers. By 1940, they developed a standardized 300-liter, 79-gallon, light alloy drop tank for longer-range operations. The principle was established. You carried extra fuel in external containers, burned it first during cruise, then dropped the tanks when they were empty or when combat became imminent. But external tanks had significant disadvantages. They imposed serious drag penalties, increasing fuel consumption. They added weight. They reduced the aircraft's maneuverability. They took up hardpoints that could otherwise carry weapons. For most fighter pilots, they were an acceptable compromise for transit to a patrol zone or ferry flights, but they were never ideal, just necessary. American fighters had been equipped with drop tanks almost from the beginning of the war. The problem wasn't that drop tanks were unavailable. It was that conventional drop tanks on conventional fighters didn't extend range far enough. The mathematics still didn't allow single-engine fighters to reach Berlin and back. The P-51 Mustang entered development in 1940 as a British request. The Royal Air Force wanted a long-range fighter that could be produced quickly. North American aviation designed it rapidly, and it entered British service as the P-51A with an American Allison engine. The aircraft was fast, nimble, and had potential, but performance at high altitude was disappointing. More critically, its range was limited. The original P-51A couldn't compete with the Spitfire, and certainly couldn't provide long-range escort. The breakthrough came through a proposal by the Rolls-Royce company. What if the P-51 airframe, which was aerodynamically clean and had a well-designed cooling system, was mated to a Rolls-Royce Merlin engine, the same engine that powered the Spitfire? The Americans acquired Merlin engine manufacturing rights, and North American began retrofitting P-51s with Merlins. The result was revolutionary, but the Merlin engine alone wasn't sufficient. The real transformation required multiple innovations working together. The P-51B, which entered service in December 1943, received a critical modification. A fuselage fuel tank behind the cockpit added 85 gallons of internal fuel capacity, increasing total internal capacity from 184 gallons to 269 gallons. This 30% increase in fuel capacity was fundamental. Then came the drop tanks. Early versions carried 75-gallon paper tanks, manufactured in Britain by pressing resorcinol glue-impregnated craft paper over wooden forms. The paper tanks were cheap, light, and adequate, but they leaked fuel after a few hours because the glue slowly dissolved from the solvent effects of aviation fuel. They were strictly one-time use items, filled right before takeoff. Pilots were required to drop partially full tanks at specified drop zones if missions were scrubbed. No one wanted leaking fuel on recovery. By early 1944, 108-gallon metal drop tanks became available, essentially teardrop-shaped containers that mounted under the wings or fuselage. These were more robust and could be carried safely on multiple missions. By March 1944, the P-51D appeared with 110-gallon drop tanks. The progression was straightforward. More fuel storage, extended range. But how you managed that fuel made all the difference. P-51 pilots received detailed instructions about fuel management, which tanks to use, in what order, and at what altitudes. On takeoff, pilots used the rear fuselage tank first, which affected the aircraft's center of gravity. You didn't want to engage in combat with all your fuel concentrated in the rear fuselage. the aircraft would be sluggish and difficult to maneuver. So the procedure was standardized. Burn the fuselage tank down to roughly 40 gallons before crossing into German territory. Then switch to the drop tanks. Burn those off during cruise at economical power settings. Drop the now empty tanks when they became unnecessary for reaching home, or immediately if enemy fighters appeared. The result was aircraft that could carry 419 gallons total with 75-gallon drop tanks, nearly double the internal capacity of Spitfires. With the later 110-gallon tanks, total capacity reached 489 gallons. Combined with the Mustang's exceptional fuel efficiency, the Merlin engine at cruise consumed only 65 gallons per hour compared to 100 gallons per hour for the P-47 Thunderbolt at the same speed. This translated to genuine long-range capability. To understand why the P-51's range advantage was so revolutionary, and why German pilots couldn't comprehend it, you need to understand the mechanics of how the system actually functioned, and why it was so efficient. Start with the fundamental principle: fuel is weight. The more fuel you carry, the heavier your aircraft becomes. Heavier aircraft require more power to maintain altitude, climb, and maneuver. More power burns more fuel. This creates a vicious cycle. The extra fuel you carry to extend range actually consumes some of that extra fuel just to lift its own weight. You gain some range advantage, but not as much as simple arithmetic suggests. This is why external tanks made sense. You carried fuel in containers mounted below the wings or under the fuselage where they didn't need to be integrated into the aircraft structure. You burned this external fuel first during cruise flight when you were at altitude and traveling at steady speeds. The aerodynamic drag penalty from the external tanks was paid during transit to enemy territory, when you were traveling at economical speeds, not fighting. Then, when fuel in the external tanks was depleted, you jettisoned them. Suddenly, your aircraft became clean, streamlined, maneuverable. The drag disappeared. You retained your internal fuel for combat and return flight. For most fighters, this provided marginal benefit. The Bf-109, the German fighter everyone feared, carried internal fuel capacity of only about 85 to 100 gallons typically. Even with a 79-gallon drop tank, it barely achieved 200 miles of combat radius. That meant German pilots could fly about 200 miles away from their base, fight for a reasonable time, and barely make it home. Berlin was roughly 300 miles from German fighter bases in the west. But German pilots flying from bases near Berlin could provide superior defensive capability right over their home territory. The advantage was tactical and geographic, defending your own airspace where you could bail out and potentially be rescued, unlike Allied pilots who'd be captured if shot down. The P-51 approached the problem differently. The airframe was aerodynamically superior to both the Bf-109 and the FW-190. North American aviation obsessed over drag reduction. They smoothed every riveted surface. Engineers discovered that removing certain rivets entirely and replacing them with flush rivets saved enough drag to add 10 to 15 knots of top speed, and that mattered for fuel efficiency at cruise speeds. The wing design incorporated laminar flow airfoil sections, which reduced skin friction drag. The radiator wasn't simply bolted on. It was integrated into a carefully designed duct system that created what became known as the Meredith effect. The Meredith effect was subtle but significant. British engineer F.W. Meredith had published theoretical work in the 1930s demonstrating that if you designed a radiator duct properly, the heat-expanded air exiting the radiator could actually produce a small amount of thrust. The air would be compressed and slowed as it entered the intake scoop, would absorb heat from the radiator, then accelerate and expand as it exited through a carefully shaped exit duct. This thermal energy could translate into propulsive thrust. North American aviation's designers understood Meredith's work and deliberately shaped the P-51's radiator ducting to exploit the effect. The distinctive belly scoop under the fuselage wasn't simply for cooling efficiency. It embodied this principle. Test data suggested the Meredith effect may have provided little net positive thrust, possibly less than theoretical predictions, but the careful ducting design certainly minimized cooling drag compared to aircraft with cruder radiator systems. All these factors combined, laminar flow wings, meticulous surface finishing, efficient radiator design, the addition of the fuselage fuel tank, meant that the P-51B with a Merlin engine was not only faster than earlier Mustangs but also far more fuel efficient. The aircraft could cruise at economical power settings at altitude without excessive fuel consumption. This efficiency was multiplied over long-distance missions. Every gallon of fuel went farther in a P-51 than in any other fighter available. Now add the drop tank system. The P-51B carried 269 gallons internally. Add 275-gallon external tanks and you reached 419 gallons total. Pilots would depart England at full combat weight, climbing to altitude while establishing cruise power settings. They'd burn the fuselage tank first, which also solved the weight and balance problem of carrying excess fuel in the rear fuselage during combat. By the time they reached German airspace, the fuselage tank would be nearly depleted, typically to about 40 gallons remaining, roughly 20 minutes of flight time. Then they switched to the drop tanks. The external tanks fed fuel to the engine while the pilot maintained economical cruise power. In the thin air at 28,000 feet, with manifold pressure set to perhaps 35 inches, fuel consumption dropped to survival levels, perhaps 50 to 60 gallons per hour. At this consumption rate, 150 gallons, the 275-gallon drop tanks combined, provided roughly 2.5 to 3 hours of cruise flight. Let's do the mathematics for a typical escort mission. Depart England, climb to 28,000 feet, 30 minutes, uses perhaps 60 gallons from the fuselage tank. Cruise eastbound toward German territory while the drop tanks feed fuel. 6 hours of flight time possible. Climb and fight over Berlin for 20 minutes at full power. Uses 200+ gallons. Cruise westbound back toward England at economical settings. 3 hours possible on remaining internal fuel. Total flight time, 9 to 10 hours. Total range, approximately 850 to 900 miles from base to target and back. The numbers that seemed impossible to German calculations were actually inevitable once you combined several factors. Larger internal fuel capacity in a clean airframe, external drop tanks, exceptional aerodynamic efficiency, and a fuel-efficient engine. The system wasn't a breakthrough in any single element. Every component existed before. The revolution was in integration and application. German pilots, by contrast, couldn't match this fuel efficiency. The Bf-109 had high specific fuel consumption relative to the P-51. The FW-190's BMW radial engine, while powerful, was thirstier. A FW-190 might manage 60 to 70 gallons per hour at economical cruise, only slightly better than a P-51, but the FW-190 carried perhaps 115 to 120 gallons of internal fuel and only a single drop tank, if any. Combat radius was barely 200 miles. The asymmetry was devastating. German fighters operating from bases in Germany could defend Berlin effectively because they weren't far from home. But P-51s operating from England, 250 miles away, could fly to Berlin, engage in combat, and return. The range advantage wasn't slight. It was transformative. It meant that every German fighter base, every German target, every German city suddenly became accessible to Allied fighters that could stay on station, fight effectively, and come home. German high command initially didn't believe reports of P-51s over Berlin. Göring issued an infamous order. Any pilot claiming to have seen American single-engine fighters over Berlin would be arrested for cowardice and spreading defeatist propaganda. It was mathematically impossible. The reports were lies. The pilots were either hallucinating or fabricating excuses for failures. The pilots weren't lying. The mathematics that had seemed ironclad were based on incomplete information. German aeronautical engineers had calculated what should be possible. They hadn't accounted for drop tanks used in conjunction with one of the most aerodynamically efficient fighters ever built, piloted by crews trained in meticulous fuel management. The first American heavy bomber strike against Berlin came on March 4, 1944. The 8th Air Force dispatched 730 bombers escorted by 796 fighters. Among the escort fighters were 175 P-51B and P-51C Mustangs, enough to provide coverage for the bomber streams, though not enough to cover every formation simultaneously. The lead fighter group was the 4th Fighter Group, commanded by Colonel Don Blakesley. Blakesley had flown over 500 combat missions, more than any American pilot in the war. He'd seen the cost of unescorted bombing campaigns. He'd watched too many B-17s go down in flames because American fighters had to turn back at the edge of German airspace, leaving bombers defenseless. The night before the Berlin mission, Blakesley's pilots attended their briefing. The illuminated map of Europe showed a red tape stretching from their base in southern England all the way to Berlin. The route was explained. P-47 Thunderbolts would accompany the bombers to the German border, then turn back. Spitfires would provide some additional support, but the P-51s would continue. They would accompany the bombers over Berlin itself, provide top cover during the bombing run, and escort them back out. One of Blakesley's pilots whispered to a companion, "We're actually going to Berlin." The route took the fighter-bomber formation over the North Sea, across the Dutch coast near the Zuiderzee. It was German hunting ground. The Luftwaffe maintained fighter squadrons specifically to intercept Allied formations crossing into Dutch airspace. Twin-engine Messerschmitt Bf-109s and Focke-Wulf FW-190s climbed from bases at Magdeburg, Kassel, Erfurt, Halle, and Leipzig, racing to intercept. Blakesley's Mustangs carried two 108-gallon drop tanks under each wing, the newer metal tanks that replaced the earlier paper versions. Total fuel capacity, 489 gallons. Each pilot had burned his fuselage tank down to about 40 gallons during the climb to altitude. They'd switched to the drop tanks during cruise flight over Holland. Now, as German fighters began to appear, they managed the engagement strategically. The standard Luftwaffe tactic was direct attack. German pilots would dive at high speed through the fighter screen, try to get a quick pass at the bombers, then zoom back up for another pass. The superior rate of climb of German fighters at high altitude gave them tactical advantages in those climbing attacks. But they expected the American escorts to turn back eventually. The Germans had years of experience watching P-47s and Spitfires depart when fuel ran low. What happened over Berlin was different. German pilot reports from the engagement describe confusion. At first, from distance, the Mustangs were mistaken for P-47s. They're both single-engine fighters with similar silhouettes at high altitude. German pilots expected them to turn back at the P-47's maximum range. When they continued east past that point, continuing to provide escort over Berlin itself, confusion turned to alarm. The 4th Fighter Group's engagement over Berlin was relatively brief. They covered the bomber stream for the bombing run, then began the journey home. They claimed 5 confirmed German fighters shot down and suffered no losses themselves. More significantly, every bomber in their assigned group reached the target safely. But the real shock came when German pilots understood what had happened. The Americans had just done something every German fighter pilot's mathematical knowledge said was impossible. They'd flown 600 miles from England carrying bombs. Wait, no, the fighters weren't carrying bombs. They were just armed fighters. They'd flown 600 miles into Germany, fought, and were flying 600 miles back. The psychological impact was immediate. Major Gunther Rall, commanding JG-11 at the time and one of Germany's most experienced fighter pilots, encountered P-51s at 28,000 feet directly over Berlin. Rall was no novice. He'd accumulated 275 aerial victories, carried the Knight's Cross with oak leaves and swords. He understood aircraft performance. He understood fuel calculations. When he saw P-51s over Berlin, hundreds of miles from England, he immediately grasped what it meant. After landing, he told his squadron, "The Americans have solved the range problem. The war is lost." Heinz Nock, an Oberleutnant, first lieutenant, in JG-54, faced an even more brutal lesson. On April 29, 1944, Nock was scrambled to intercept bombers heading to Berlin. He climbed through broken clouds and spotted the bombers. He dove toward them, trying to press an attack, attempting the standard Luftwaffe tactic of ignoring the fighters and going for the bombers. A P-51 followed him down. Nock's account in his wartime diary is raw and immediate. "The Mustang was there again, not 100 feet behind me. The flames are licking closer now. I can feel the heat. With the aim of opening the way to Focke-Wulf's, I attract the escort of fighters towards me." Nock was shot down and bailed out, landing with serious injuries. When he regained consciousness, an American fighter pilot was standing over him, the same Mustang pilot who'd shot him down. But what's significant about the encounter is that Nock, an experienced Luftwaffe pilot, was caught in circumstances he didn't expect. He'd expected American fighters to be limited in range and endurance. The The Mustang operating far inside Germany defied those expectations. By late spring 1944, the pattern was established. American bombers could be escorted to almost any target in Germany. German fighters couldn't prevent interception during the bombing run. Worse, the escorts weren't just defensive. Doolittle had ordered that fighter groups be freed from close escort duty and instead conduct fighter sweeps ahead of the bomber formations, aggressively seeking out Luftwaffe fighters to engage. This was devastating for German pilots. They could no longer position their fighters beyond Allied escort range and wait for the escorts to turn back. The escorts didn't turn back. Instead, American fighters now came looking for them, hunting them far from home bases where German pilots couldn't be rescued if shot down. The engagement pattern that emerged was characterized by multiple formations of Mustangs, sometimes operating at different altitudes. High-cover fighters would position themselves between the bombers and the sun, forcing attacking German fighters to climb through the escort screen. Experienced aces like Chuck Yeager and Bud Anderson, who would fly 116 missions in the P-51D nicknamed Old Crow, became expert at these engagements, using the Mustang's superior maneuverability at altitude to devastating effect. German pilots adapted their tactics. They began adding armor plating to their fighter aircraft, specifically heavy FW-190 variants optimized for head-on attacks against bombers rather than dogfighting with escorts. These armored Sturmgruppen, attack groups, became even less maneuverable, making them more vulnerable to P-51s. The tactical spiral became self-defeating for Germany. Measures to counter one threat created vulnerabilities to another. To understand why the P-51's range advantage was so revolutionary, you need to directly compare it with what German pilots were flying. The Messerschmitt Bf 109 had evolved through multiple variants by 1944. The most common versions German pilots were flying, the G and K variants, featured impressive climb rates and high-altitude performance. A Bf 109G could climb to 30,000 feet in roughly 9 minutes, faster than the P-51. At high altitude, above 25,000 feet, the Bf 109 had performance advantages. Maximum speed was comparable, around 400 miles per hour at altitude for the Bf 109G versus 410 miles per hour for the P-51B at similar conditions. But the Bf 109 had severe range limitations. Internal fuel capacity was approximately 85 to 100 gallons depending on variant. With a single 79-gallon drop tank, maximum capacity reached barely 165 to 180 gallons. Combat radius was roughly 200 miles on internal fuel alone, or about 300 miles if the pilot managed fuel extremely carefully and flew at economical cruise power settings. The Bf 109 had virtually no loiter time. A Bf 109 arriving at a bomber formation could engage for perhaps 15 to 20 minutes before fuel warnings forced a return to base. The Focke-Wulf FW-190 had different characteristics. The BMW radial engine was powerful and provided excellent performance at low to medium altitudes, but performance fell off significantly above 25,000 feet. The FW-190 had slightly larger fuel capacity than the Bf-109, roughly 115 to 120 gallons internal, plus capacity for a drop tank. Combat radius was comparable to the Bf-109, around 250 to 300 miles at best. The FW-190 actually burned more fuel than the Bf-109 at similar cruise speeds because the radial engine was less fuel efficient than the Bf-109's inline Daimler-Benz engine. Now compare the P-51B, 269 gallons internal capacity plus 150 gallons in two 75-gallon drop tanks, totaling 419 gallons. The P-51C had similar capacity. The P-51D carried 110-gallon drop tanks, reaching 489 gallons total. Combat radius with this fuel load, accounting for climb to altitude, cruise, combat, and return, was roughly 750 to 850 miles with the 75-gallon tanks, extending to 850-plus miles with the 110-gallon tanks. The asymmetry is stark. A P-51 could carry roughly 2.5 times the fuel of a Bf-109 or FW-190. This didn't translate to 2.5 times the range, due to the additional weight and drag of carrying such large fuel loads, plus the efficiency factor of burning fuel just to lift extra weight. But the range advantage was still absolutely enormous. More importantly, the P-51's fuel efficiency meant that every gallon carried translates to more range than in German fighters. The P-51B burned approximately 65 gallons per hour at cruise power settings at altitude, economical cruise at perhaps 35 to 40% power. This was exceptional for the era. The Bf-109 might achieve 50 to 60 gallons per hour at similar settings. The FW-190, with its less efficient radial engine, might burn 70 to 80 gallons per hour. But even accounting for this efficiency advantage, the mathematical reality was that P-51s could reach targets German fighter pilots considered unreachable. P-51 pilot departing England with 489 gallons could climb to altitude, cruise 600 miles east toward Berlin, stay on station for 15 to 20 minutes of combat, cruise 600 miles back toward England, and land with fuel reserves for diversion to alternate airfields or emergencies. A Bf-109 pilot couldn't achieve this. Even with exceptional fuel management, combat radius was fundamentally limited by the amount of fuel that could be carried in the airframe structure. The specific numbers evolved throughout 1944. By mid-1944, P-51D Mustangs with 110-gallon drop tanks began appearing in quantity. These extended combat radius to roughly 850 to 900 miles, enough to reach Berlin, fight for 20 minutes, and return to England. German calculations said this was impossible. Allied pilots were proving it was not only possible but routine. There was another crucial difference in how each side used their fighters. American doctrine emphasized having fighters available continuously throughout a bombing mission. Fighter groups would be staggered at different points along the route. P-47s and P-38s providing early escort, P-51s providing deep penetration escort over the target, then P-47s again providing covering support on the withdrawal. This relay system meant bombers were never unescorted. German doctrine, by contrast, emphasized concentrated attacks. German fighters would scramble from multiple bases, climb to altitude, and attempt mass attacks at times and places where they had local numerical superiority. This worked when Allied fighters were limited in range. It failed when P-51s could stay on station longer, provide continuous coverage, and actually seek out German fighters rather than simply defend bombers. By the end of 1944, the performance comparison had become almost tragic from the German perspective. New FW-190D variants were appearing with better high-altitude performance, and the Ta-152 was entering service with capability to reach 40,000 feet and fly at 400+ mph at extreme altitudes. But these aircraft arrived in small numbers, too late to affect the outcome. The fundamental strategic advantage, the P-51's ability to range deep into Germany, fight effectively, and return, had already decided the air war. The strategic impact of the P-51's range advantage can be measured in specific, quantifiable ways. Before the P-51 arrived in quantity in early 1944, American bomber losses were catastrophic. The October 1943 Schweinfurt raid lost 60 bombers, a 20% loss rate. The August 1943 Schweinfurt-Regensburg mission lost 60 bombers plus 50 more damaged beyond economical repair. These losses were unsustainable. The 8th Air Force suspended deep penetration daylight bombing raids deep into Germany. When daylight bombing resumed in early 1944 with P-51 escorts, the losses changed dramatically. During Big Week in February 1944, the 8th Air Force dispatched more than 3,500 bomber sorties with P-51 escorts while also incorporating P-47 and P-38 fighters. Total bomber losses were 247 aircraft, a loss rate below 7%. This was still significant, more than 2,000 casualties among bomber crews, but it was survivable. Bomber crews now had realistic odds of completing their required 25 mission tours. By late spring 1944, with P-51s providing continuous escort, bomber losses had fallen to roughly 3% on average, sometimes dropping below 2% on missions where fighter cover was complete. The arithmetic is simple. In 1943, losses were unsustainable. In 1944, with P-51 escorts, losses became acceptable. Bombing campaign resumed. German industry faced continuous assault from 1944 onward. The attrition to German fighter pilots was equally dramatic. During Big Week in February 1944, German fighter units lost approximately 100 experienced pilots, killed or captured, along with 400-plus fighter aircraft. German pilot training couldn't replace losses at this rate. More significantly, experienced pilots couldn't be replaced. A veteran Luftwaffe pilot who'd survived since 1940 represented irreplaceable expertise. When P-51s killed or captured these pilots at accelerating rates, German fighter effectiveness declined not just in numbers but in expertise. By mid-1944, the Luftwaffe was facing a desperate situation. German aircraft production was holding up. Germany actually produced more fighters in 1944 than 1943. But German pilot training was collapsing. Replacement pilots had perhaps a few hours in operational aircraft before being sent into combat against P-51 pilots who'd accumulated dozens of combat missions. The kill ratio statistics became increasingly one-sided. By war's end, P-51s had achieved approximately an 11-to-1 kill ratio against Luftwaffe fighters, roughly 11 German aircraft destroyed for every P-51 lost in air combat. This wasn't because Mustangs were dramatically superior fighters in dogfighting. Many German aircraft were more maneuverable. It was because P-51s could be present in numbers, could stay on station, could engage when it was advantageous, and could disengage when necessary. The strategic impact was decisive. The combination of P-51 range capability and American industrial production. The USAF could replace fighter losses. Germany couldn't, broke German air power. By June 1944, when D-Day came, the Luftwaffe had already been essentially defeated in the daylight sky over Germany. German fighters couldn't prevent B-17s from bombing Berlin. They couldn't prevent P-51s from escorting them. The air war was decided. German pilots understood this. Adolf Galland, commanding German fighter forces, stated bluntly, "The day I saw Mustangs over Berlin, I knew the war was lost. This wasn't defeatism or cowardice. It was technical assessment." German fighters couldn't match the combination of P-51 range, numbers, pilot skill, and American industrial capacity. The P-51 wasn't static. As the air war evolved through 1944 and 1945, the aircraft continued to develop, and the drop tank system evolved alongside it. The earlier 75-gallon paper drop tanks gave way to 108-gallon and eventually 110-gallon metal tanks. Solid teardrop-shaped containers that were more durable and could be used repeatedly. By late 1944, when very long-range P-51s were flying missions to distant targets, even larger tanks appeared. P-51s operating from the Pacific Theater in 1945 carried 165-gallon drop tanks, extending combat radius toward 1,600 miles. The operational procedures evolved as well. Initially, pilots were instructed to keep drop tanks attached during combat if fuel consumption calculations suggested they might need them. But operational experience quickly showed this was dangerous. Drop tanks added weight and drag, making the aircraft sluggish in dogfights. Experienced pilots would drop tanks immediately at the first sign of combat. This led to tactical innovations. When fighter sweeps were planned, pilots would sometimes arrive at patrol areas with drop tanks still attached, prepared to engage any German fighters encountered and then assess fuel status. If they had time and fuel, they'd circle back and continue patrol. If not, they'd drop tanks and return. This flexibility gave American fighters enormous tactical advantages over German fighters that were bound by finite fuel capacity and limited by geography. They had to be near home bases to have any chance of recovery if shot down. The laminar flow wing design remained fundamental to the P-51's efficiency throughout its service life. Later variants like the P-51H featured improved engines, additional internal fuel capacity, and refined aerodynamics, but the fundamental principle, an aerodynamically clean airframe that could carry large amounts of fuel and deliver it over extreme distances, remained constant. The drop tank system itself evolved beyond the Mustang. By war's end, most American fighter aircraft carried drop tanks. The P-47 became far more effective when equipped with larger tanks. Even the P-38 eventually benefited from improved drop tank systems that extended its range. But none of these aircraft achieved the combination of fuel efficiency, range, and combat effectiveness that the P-51 demonstrated. The P-51's drop tank system became the template for extended-range fighter operations in the jet age and beyond. Modern fighter aircraft, from the F-4 Phantom through the F-15 Eagle to the F-16 Viper. All carry external fuel tanks. The principle remains identical. Carry extra fuel in expendable external containers, burn it during cruise, drop the tanks before engaging, and retain internal fuel for combat and return. Stealth considerations have complicated matters. Modern jets like the F-35 have been struggling with how to add drop tanks without compromising stealth characteristics, but the fundamental concept persists. The lessons learned in World War II about the value of range and loiter time have profoundly shaped military aviation doctrine. Modern air forces still emphasize the ability to maintain continuous presence over operational areas. Air superiority isn't just about having the best fighter. It's about having fighters available continuously, capable of staying on station, and able to dominate through presence and persistence. The metrics have changed. Modern fighters operate at hypersonic speeds. Drop tanks might be designed to reduce radar signature. Refueling in mid-air through boom systems provides alternatives to external tanks. But the fundamental principle, that extended range allows aircraft to maintain presence over larger areas and achieve strategic objectives that wouldn't be possible with reduced range, remains as valid as it was in 1944. More broadly, the P-51 story illustrates a principle that transcends aviation. Sometimes the most decisive military innovations aren't revolutionary new technologies, but rather clever applications of existing technologies in ways that fundamentally change strategic balance. Drop tanks existed before the P-51. The problem was that previous aircraft couldn't leverage the advantage effectively. The P-51, through a combination of aerodynamic efficiency, fuel economy, and internal design changes, made drop tanks strategically significant. The German Luftwaffe had drop tank technology. They used it on their fighters, but they never achieved the fuel efficiency or the overall range capability that American designers managed. This failure wasn't due to lack of expertise. German aeronautical engineers were world-class. It was due to different priorities, different aircraft designs that emphasized other characteristics, and perhaps most significantly, a failure to anticipate how American engineering and industrial capacity would synthesize existing technologies into something that exceeded German expectations. When Galland saw Mustangs over Berlin, he understood that Germany had lost an air war not because of cowardice or inadequate pilots, but because American engineers had solved a problem the German high command had believed was mathematically unsolvable. That realization, more than any other factor, broke the Luftwaffe's will.